All right, before we can continue talking about our polynomials, we need to figure out how exponents work. Okay, we've done a little bit of work with exponents, but now we're talking about combining exponents, adding, subtracting, multiplying, dividing exponential terms. So let's just refresh our memory on what it means to be an exponent. Okay, this is an exponential number. The little number is called the exponent. The big number is called the base. What the exponent means is it's shorthand for multiplication, right? It means you're going to multiply the base, the big number, times itself this many times. So this means 1, 2, 3, 4, 5, 6 2's multiplied all together, right? It's not 2 times 6, okay? It's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the 6th is 64. Okay, so the base is 2, the exponent is 6. So you can read it 2 to the 6th power or just 2 to the 6th. Okay, so that we know. That we've dealt with. Okay, so this says evaluate and name the base and the exponent. Okay, so on this one the base is 2 and the exponent is 4. So what that means is I want to multiply that 2 times itself 4 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Now, look at the difference of these two. We've talked about this before. Remember, the exponent only goes on the one number it's sitting on. This right here, this exponent has nothing to do with that negative. This exponent has nothing to do with that negative. If it did apply to the negative, the exponent would be sitting on parentheses, meaning it goes to the entire thing in the parentheses, not just the 2, but the negative. So this one is negative, and then 4 2's multiplied together. Okay, the base of this is 2, not negative 2. This base is negative 2, right? The base is the thing the exponent goes to. And this exponent only goes on the one number it's sitting on. So this is negative 16. Now this one, the base is negative 2. So what it means is you're actually going to multiply the negative 2 times itself 4 times. Okay, and 4 negatives multiplied together is a positive. Not the same thing. Be careful about those signs. Okay. Okay. So here's just some information restating what we just found out, that negative a to the n and then negative a all to the n are not necessarily the same. So be careful with that. Okay, now we're going to start talking about some rules. And the first thing we have is something called a product rule. Product means multiplying. So if you're multiplying two exponential numbers that have the same base, they have to have the same base, right? Or you can't multiply them. But if they have the same base, all we have to do are add the exponent and keep the same base. The base is not going to change. Think about what this means. Okay, so if you had 5 cubed times 5 to the 4th, 5 cubed is 5 times 5 times 3 5s. But then you're just going to multiply it by 4 more 5s. So really all together, you're multiplying by 1, 2, 3, 4, 5, 6, 7. That's why that's our rule. Okay, you keep the base the same and you add the exponents. So let's practice that. Okay, since the base is the same, I'm going to keep the base the same, and because it's multiply, I'm just going to add the exponents. 5 and 8 is 13. Okay, so this is saying, oh, I've got 7 times 7 times 7 times 7 times 7 times, and then 8 more 7s, altogether 13 7s. This base is -2, so it stays the same. And add the exponents. 4 plus 5 is 9. This base is y, so it stays the same. Uh-oh, what's this exponent? Right, 1, right? If there's not an exponent written, it's understood to be a 1. So 5 plus 1 is 6. Okay, use the product rule. Notice it says, if possible, the bases are the same, so you add the exponents. Uh-oh, the bases are not the same. I cannot use my exponent rule. Doesn't mean I can't simplify this, because I know 3 times 3 is 9 and 2 times 2 is 4, so that's 36. But it's not using an exponent rule. I cannot use any of my exponent rules if the bases aren't the same. And this one, be very careful about this one. That's not a product. Remember, we've mentioned before, we never, ever have rules or properties or shortcuts that involve adding and subtracting, right? The plus sign, be careful, don't do it. So this is just 2 cubed, or 8, plus 2 squared is 4. I do not have an exponent rule if the bases are not the same, and if it's not a product and actually quotient, a product or a quotient, not for adding or subtracting. We don't have our quotient rule yet, but we're going to soon. Okay. So think about this. Remember what that means. If we have a number written right next to a variable, it means multiply. So really, all of this stuff is being multiplied. And multiplication is commutative. So that means I can change the order. 2 times 3, 3 times 2. So I can put the numbers together and the variables together. So 5 times 4 is 20. And then because these bases are the same and it's a product, I can add the exponents. Okay. Okay. So this is just a caution about the things that we already talked about. Be careful. There is no exponent rule for adding. This is what we just got through talking about. If your terms are the same, if you have 7k squareds and you're going to add 3k squareds, right, you combine them. And that k squared doesn't change, right? 7 pencils and 3 pencils is 10 pencils. The pencil part doesn't change. 7k squareds plus 3k squareds means I just have 10k squareds. But if you're multiplying, your exponent's going to change. You multiply the numbers, 7 times 3, and then k squared times k squared means k times k times k times k. 4 k's being multiplied. Okay, now that was our product rule. Now we've got an exponent rule. Okay, and it says if I have an exponential number being raised to another exponent, I can multiply the 2 exponents. Okay, so look at this example. Think about what this means. This is 4 cubed because really that means, oh, that's 4 times 4 times 4. But then if I want to square this, notice how many I wind up with. 1, 2, 3, 4, 5, 6. Same thing as 3 times 2. Okay, so that's our power rule. Let's look at that. Okay, I have an exponential number raised to an exponent. So that says that you can just multiply the 2 exponents. Right? My base is 4. 8 times 6 is 48. Your base is n. 7 times 3 is 21. Your base is 2. 5 times 8 is 40. Okay. So if I have an exponent on parentheses, it goes to everything in the parentheses, right? Everything in the parentheses. So the 5 will get a cubed and the h will get a cubed. Now, again, be careful. And this one, the 5 does not get the cube, right? The 5 does not get the cube. Only the one thing it's sitting on. Unless it's on parentheses, then it goes in everything. Applies to everything. Okay, since that exponent of 4 is on parentheses, that 2 gets the power, the a gets the power, the b gets the power, and the c gets the power. Okay, and if this exponential number is one that you can evaluate fairly easily without a calculator like this one, and eventually every single number that has an exponent you're going to be expected to evaluate physically. This is something we can simplify. We can do that math. Now, like that, we had 2 to the 40th a while ago. They're not going to make you multiply 2 times itself 40 times. But 4, yeah, 2 times 2 is 4, times 2 is 8, times 2 is 16. So really, this looks like this. Okay, so my question is, does that 2 go on that 5? You're right, I hope. No, it does not. Only what's inside the parentheses. So that 5 just stays 5. Now, the 2 goes on everything in there, so it goes on the x. And now it goes on the y too, but now I've got to incorporate that other power rule. Oh, if there's already an exponent there, then I multiply. Notice there's a 1 there, and that's the same thing, 1 times 2. That's why we got a 2. 3 times 2 is 6, though. But it did not go on the 5. The 5 was not in parentheses. Okay. The 7, not in parentheses. But the 2 is in parentheses, so it gets the cube. The m gets the cube. The n to the 5th gets the cubed, but when you cube n to the 5th, it's 5 times 3 is n to the 15th. And then p to the 7th would be p to the what? 21. Now, if there's still math you can do, you've got to do that math, right? And 2 cubed, 2 times 2 is 4, times 2 is 8. So this is 7 times 8. And then these all have different bases. There's nothing you can do if the bases are different, only when the bases are the same. Okay. So be very careful about this one. Okay. So I don't believe they're going to make you multiply 3 times itself 20 times. So they'll probably let you leave that as a 20. But I got a negative here. This even exponent has nothing to do with that negative, right? If I didn't have this parentheses and that other exponent, this would be negative 3 times 3 times 3 times 3, or negative 81. That number is negative 81. 3 times 3 times 3 times 3, and 1 negative. But now that is raised to the 5th power. So if I had to multiply this out, I would have 5 negatives, meaning this final answer is going to stay negative. And then 3 to the 4 times 5 is 20. Okay, once again, none of these rules apply to a sum, right? The exponent on parentheses goes to everything inside the parentheses only if everything inside the parentheses is being only multiply and divide. We're going to see that in a minute. Divide also. not plus or minus, not plus or minus. Okay, here's where we're going to see the divide, right? As long as it's multiply or divide, then everything inside the parentheses gets that exponent applied to it. So here, for example, we would have 2 to the 4th over 5 to the 4th. Okay, and this one would be x to the 7th over y to the 7th. Okay, now ideally if you just have numbers, you should multiply that out. They're getting a little large on you here, but they probably expect you to multiply that out. So 2 times 2 is 4, times 2 is 8, times 2 is 16. And on the bottom, 5 times 5 is 25. So think about this. So that's 5 squared is 25. When you have 5s, think about quarters. 5 squared is 25. So then if I did it again, if I multiplied this by one more 5, what's 5 quarters? Oh, that's $1.25, 1.25. So there's 2, 3. I need one more 5. What if I had $1.25 times 5? And if you need to come over here and do that, fine, do that. But if you could put it in terms of dollars, sometimes people can do that. Oh, I'd have $5 plus 5 quarters, $6.25, right? Okay, so there's a list of your rules that we have so far, right? We've got a product rule, and then we've got so far 3 power rules. So that's just a handy little chart putting it all together for you. Okay, so now on this one, just like always, let's get rid of those parentheses. So we have 3 squared over 4 squared. Then it's times. Remember, anytime you have fractions, make them all look like fractions so we know what's going on. And we're multiplying. When you multiply fractions, you multiply straight across the top. So because they have the same base, I can just add the exponents. I've got a 3 times 3 times 5 more 3. So altogether, that's 7 3s being multiplied together. And then 4 squared times 1. Okay, 4 squared is 16. 4 times 4. Okay, let's see if we can come up with 3 to the 7th. 3 times 3 is 9. All right, so let's do this. So 3 squared is 9. 3 squared is 9. So that's 81 for 4 of them, right? So if I did it times 3 again, that would be 3 to the 5th, would be 243. And then if I did it times 3 again, that would be 6 3s, right? 1, 2, 3, 4, 5, 6. 3 times 3 is 9. 3 times 4 is 12. So that's 729, and then I'd still have to multiply by one more 3. This is probably bigger than what they're expecting you to do. So they may let you leave it like this. They should on one like this. 3 times 9 is 27. 3 times 2 is 6, 7, 8. 3 times 7, 21. Okay, so here, first of all, I got to get rid of these parentheses. When I look inside the parentheses, there's nothing to do, right? I have an M and an N, different bases. So getting rid of the parentheses, that means I have 7 cubed, M, 2 times 3 is 6, and then 1 times 3 is 3. And then it's times 7 to the 5th, M to the 5th, N to the 10th. Oh, but now look, I've got some bases that's the same, and I'm just multiplying a bunch of stuff with same bases. The ones that have bases the same, I can put together. 3 plus 5 is 8. Okay, and then the m's, there's 6 m's times 5 more m's. The n's, there's 3 n's times 10 more n's. And now that, I'm not going to multiply that. They better not ask you to multiply that out. Now that I have each individual base written only one time, it's simplified. Okay, so to get rid of these parentheses, we would have 2 to the 6th, x to the 6 times 3 is 18, exponent raised to an exponent you multiply, y to the 6th. And then 2 to the 10th, x to the 70th, y to the 40th, 4 times 10. Now that we're multiplying, we add the exponents. Exponent raised to an exponent, multiply. Exponential numbers being multiplied, add the exponents. So 2 to the 16th. Okay, so here's 18 x's times 70 more x's. So 70 and 18 would be 88 x's all getting multiplied together. And then here's 6 y's multiplied by 40 more y's. So 46 y's all together. Okay, now this one, 2 negatives multiplied together is positive. So that's a positive. And then I have g to the 6th, 3 times 2, and h squared. Okay, 3 negatives stays negative. Don't put your negative in here because then it's going to look like that's a subtraction problem, right? Or if you do, you got to keep parentheses around it so that it's an obvious multiplication. But I know that I'm spreading these things out. Oh, shoot. Well, I was going to use an example of, look what we did up here, what we've done on all of these previous problems, right? I'm going to take everything out of the parentheses so that I have a bunch of stuff multiplied together. So I can just put that negative in the front. Okay, we just said 2 negatives multiplied together is positive, so that negative's gone. 3 times 2, 1 times 2. But over here, this one stays, and it's a times. I don't want to put it here to make it look like a minus, so put it here. Okay, and then 3 times 2 is 6, and 3 times 5 is 15. Now I got a bunch of stuff multiplied together, right? Not being added and subtracted. It's just the number is negative. So 6 g's times 6 more g's is 12 g's altogether. And then 2 h's times 15 more h's is 17 h's. Okay, a little application problem for us. Find a polynomial that represents the area of the geometric figures. All right, well, I've got to know that the area of a rectangle is length times width, right? So here's the length, and here's the width. So length times width. Oh, that's what we were just doing, right? So that's really 4x cubed times 2x squared. So 4 times 2 is 8. If you're multiplying exponential numbers that were the basis the same, you add the exponents. So over here, I got to know the area of a triangle is 1/2 base times height, right? That's the area of a triangle. All right, so this would be 1/2 base, here's the base, times 8n to the 5th, times the height. 3n to the 4th. Okay, so it's all just multiply. Let's get rid of those parentheses. 1/2 times their fractions. All right, then let's see the fractions. Okay, look, anything that's the same in numerator and denominator can divide out. So now my denominators are just 1. I'm kind of done with that. 4 times 3 is 12. N to the 5th times n to the 4th. N to the 9th. All righty. Have fun.